Have you ever given an AI a complex set of instructions only for it to completely forget what you asked 2 prompts later? It is a lot like throwing a perfect pass to a teammate only to watch them instantly drop the ball. To hold on to those instructions, an AI uses a memory system. You can think of this like a digital notebook where it jots down lessons, a filing cabinet for organized records, or a toolbox where it saves reusable skills. No matter how smart an AI seems on the surface, its ability to actually finish a complex job is completely tied to how well that specific memory system works. If it cannot recall the right tool or the right lesson at the right time, the whole process stops. We have to fix the memory to fix the AI. That brings us to Mevolve. It asks an interesting question. Can a computer look at its own fumbling memory, figure out what went wrong, and invent a better one entirely on its own? Think of Mevolve like the sports coach you see on the left side of this screen. Just as a coach watches a team and creates new strategies, Mevolve watches the AI's digital code on the right, finding ways to improve how it remembers. Mevolve follows 4 specific, highly visible steps to coach the AI through its own development. Step 1 is to analyze. Before a good coach changes a single play, they sit down and watch the game tape to spot exactly where the team is fumbling the ball. In this split view, the film strip on the left represents Mevolve doing exactly that. On the right, it reads through folders of task logs, recordings of the AI trying to do real jobs, to pinpoint exactly when the memory let the agent down. All of those failures are gathered into a single diagnostic file called the analysis report. Every single change that follows is built directly on this exact diagnosis. No human guessing is allowed. The system only solves real problems it caught on tape. Step 2 is generation. The coach steps up to the whiteboard to sketch out one specific new play designed to fix those exact fumbles. Notice the dial turning up on the right. This is the creativity index. It is a control dial you can adjust to tell the system whether to make a safe, conservative tweak to the memory or to try a highly inventive new blueprint. The output is a new file called a generated system, but right now, as that pulsing outline shows, it is strictly a theoretical plan. It is just a recipe. A drawing on a whiteboard cannot win a basketball game on its own, and a theoretical recipe cannot run an AI program. That brings us to step 3, create. The players have to take that theoretical drawing and actually learn how to run it on the court. On the left, the play moves from the whiteboard to the floor. On the right, Mevolve turns that recipe into real Python code, plugging it into the main system so the AI knows exactly where to find and use its new memory. It then writes a build record, a created system log, that tracks exactly which pieces of code were successfully built and connected. This is the exact moment the idea stops being a sketch. It becomes real code that the AI framework can now locate and use. Finally, step 4 is validation. Before you play in the championship game, you run a practice scrimmage just to see if the team can execute the play without tripping over their own feet. As the practice scrimmage begins on the left, Mevolve runs a fast scan on the right. It checks that the code is written correctly and has all its basic startup instructions before it spends time running any massive, expensive tests. The result is stamped into a final checklist called the validated systems file. This quick check proves the new memory candidate is structurally sound enough to move forward, protecting the overarching system from collapsing during real-world use. Look at how these 4 distinct documents, the diagnosis, the blueprint, the build record, and the validation checklist, now stack perfectly on top of each other to form a solid foundation. These documents act as visible receipts. Because the AI is forced to show its work at every stage, it cannot simply hallucinate a random solution or trick itself into thinking a bad idea works when it actually fails. By breaking the work down into these separate stages, both humans and the system can inspect the mat. We can verify a real improvement rather than relying on a single blind leap of faith. Mevolve then wraps this 4-step pipeline into a continuous competition. It evaluates candidate after candidate until it crowns an ultimate winner to serve as the AI's new baseline memory. Watch the tape, draw the play, teach the play, run the scrimmage. This allows the system to systematically build and refine its own memory, using real evidence to get better with every cycle.